Our team is comprised of individuals from very diverse backgrounds. Each member is a mechanical engineering student at Lawrence Technological University. Some members are well versed in electronics and robotics applications, whereas others are mechanically oriented and skilled with their hands. Together, we were able to create a device to assist disabled workers.
We're on our way to the Services to Enhance Potential, or STEP, Northwest Resource Center in Livonia, Michigan. They work with clients who have disabilities. Their goal is to train the workers by employing them temporarily in order to develop their skills for a professional work environment. The acronym STEP also stands for Support, Teaching, Employment, and Pride. Consequently, the Northwest Resource Center aims to support, teach, and employ workers with disabilities while promoting a sense of pride in their work. The workers take part in mostly manufacturing-type jobs where they assemble components. Some examples are spray bottles for Sprayco and headrests for General Motors. According to a study by Microsoft and Forrester, 7% of working-age adults have a severe dexterity difficulty. In other words, they can't even use a computer mouse. This includes the pinch grip, push force, and power grip. Workers at STEP Central's Northwest Resource Center are faced with the task of assembling Sprayco bottles. Week after week, they spend their time straining their hands and backs, doing the same tedious tasks. First, they have to reach down to the floor to retrieve an empty bottle. Next, they insert the nozzle straw into the bottle and twist it tight. Finally, they must throw the assembled bottle assembly into a tall box sitting on the table. These tasks use all three forms of dexterity: the pinch grip, push force, and power grip. Since the workers clearly voiced their many pains and discomforts, it is clear that a solution was needed to alleviate these pains.
Our final design consisted of two components, an initial parts box and a sprayer assembler. The initial parts box eliminated all bending required by the worker when accessing the initial parts for assembly. This is due to the box placement on the table and the easy access store. The automated sprayer assembler reduced wrist pain. Our device allowed users to assemble a spray bottle with a single hand rather than using both, which eliminated strain on their wrists. This allows users with limited mobility to complete jobs at a much faster pace and earn more money despite their disability. Our prototype, we chose durable and heavy-duty materials for construction. In an attempt to cut costs in the future, the sheet of MDF we used to construct the box could be replaced with a thinner sheet. This would reduce the overall cost and make the box less cumbersome on the work surface. Likewise, we could develop our own handles for the box and construct them out of scrap MDF, which eliminates the need to purchase knobs from a supplier. Mass production and ordering in bulk will also save on construction costs.
The box holding the bottles reduced the reaching distance to within our margins. It was large enough to provide proper access to the bottles, but small enough to conserve space in the aisles. The sprayer tightener reduced wrist pain and increased the workers' productivity. In fact, it allowed workers to do the job with only one arm. Of the 10 people who tested our setup, 100% of them agreed that it reduced their wrist and back pain. As for productivity, the workers were generally more efficient using our nozzle tightener. Specifically, the workers with disabled limbs or limited dexterity could assemble a bottle in around 11 seconds, which is much less than the previous average of 18.2 seconds. Higher functioning workers were able to be more efficient without our mechanism. However, they all loved our mechanism because it reduced their wrist pain and back pain. All of the workers seemed to argue that our device made assembling bottles much more fun.
Now is the perfect time to invest in our team. We have completed extensive market research and spent many hours conducting research and development tests. We are now ready to commercialize our product to suit the needs of our customers. We look forward to conducting business with potential investors in the future.
We would like to thank Steve Slayton of STEP's Northwest Resource Center. With the help of him and his team, we were able to create a lasting partnership with STEP's clients and look forward to assisting them in the future. We would also like to thank our course instructors, Dr. Huff and Professor Morano. With their guidance, we were able to learn more about the entrepreneurial engineering design process and have the tools to professionally develop our product.
We may have only impacted workers at the Northwest Resource Center, but our mindset and skill set can be modified to suit the needs of disabled workers in various industries throughout the larger community.